Every cell in your body walks a fine line between life and death. Each cell is like a highly wired machine, constantly checking whether it has enough nutrients and oxygen and whether everything is working as it should. And if things go wrong, then that cell, like this little guy here, will initiate self-destruct. This destruction occurs every second of our lives on a massive scale. There's a constant turnover to ensure that our bodies don't become overrun with old or malfunctioning cells. Cells will self-destruct for the good of the whole, to keep the body healthy. To understand this knife edge between life and death, we need to look within the cell, at the mitochondria, which I've drawn here in yellow. Embedded within the mitochondrial membrane are a family of proteins with opposing functions, those pro-survival, which I've drawn in green, and those pro-death in blue. Now, in healthy cells, the pro-survival proteins bind and inhibit the pro-death proteins until a strong enough death signal comes along to enable the pro-death proteins to be released and initiate self-destruction. So what about cancer? Cancer cells have plenty wrong with them. In fact, the list of things wrong with cancer cells is what defines them. And yet they survive and multiply in the face of all of these defenses. So the question becomes, how do cancer cells evade death? And what can be done about it? I'm working on a disease called chronic myeloid leukemia, or CML. It's a type of blood cancer, which in its earliest stages is often very successfully treated with drugs called TKIs. However, for patients whose cancer progresses or who present in a more advanced stage of the disease, the prognosis is currently very poor. I'm looking at how these advanced cancer cells are evading their own death-inducing systems. In these leukemia cells, there is an excess of these pro-survival proteins, meaning that even in the face of a barrage of death signals, such as chemotherapy, the cells will survive. Understanding this has been the key to a more targeted approach. I'm using new drugs that block the excessive pro-survival proteins. This means that the death signals can no longer be ignored. I found that these drugs enhance the effects of the standard TKI drug treatment, resulting in greater leukemic cell death. Now, obviously, I understand that my PhD is not going to end with me curing advanced CML, but I do think that this is something to be excited about. It's rational, targeted approaches like these that are paving the way towards personalized cancer medicine, resulting in greater outcomes for patients with fewer side effects. And that's something I think we can all get behind. So with that in mind, watch this space, and thank you very much for listening.